the different type of controllers on the heat exchanger. There are three main objectives, which is to study the proportional controller, second is to study the proportional integral controller, and third is to study the proportional integral derivative controller.
Okay, now we will proceed to the methodology of our experiment today. So, first step is to power on the control system. Okay, so next you open the panel. Okay, next, okay, just open the pump for the cold water and also pump for the hot water. So, open and also open. Okay, so now, next is for the recording purpose, to get our result, we have to open this part and make sure that it record. Before that, we set our set point to 30. Set point to 30. Okay, so we set to 30 first. Okay, after that, we wait until it stabilize, and we set our PID controller by doing this. So, according to our data that we want, so we edit the value for the P and I and also derivative here. So when we have set, then we put this system to auto, and we let the system to stabilize and get the record. And not to forget to press the record button for the thing to record lah. So that's all. Okay, now when we have done our part, just press this thing to make it go a bit far, and we tell the result lah. Okay, so after we get the result, we first stop the pump of hot water first and also for the cold water. Okay, next we will go with the panel. We close the panel lah. So after we close the panel, then just switch off the main power. So that's all for the closing method. Okay, that's all.
Okay, I will talk about the flow of the hot water first. So firstly, this is the hot water tank. The flow is from down here, as you can see. This valve coming out from the hot tank, all the way it will go to this pump. Then the pump will spread the water up to the rotameter. Then it will flow to this one, pressure gauge. Then come into the heat exchanger. Then it will flow inside a tube inside this heat exchanger, 50 tubes. Then it will flow. Then it will come down here. Then it will flow back to the tank. That's all for the hot stream. Okay, now I will talk about the cold stream. The cold stream will flow from bottom here, bottom of the tank, then go through the pump. The pump will push the water up, then go to the rotameter. Then we flow to here, and inside the shell and tube heat exchanger. It will then go upward. Then it will pass through here and go back to the product tank. Then come down. The product is supplied from here. If the level is too high, the product will flow down and go to the waste. That's all. Thank you.
I will now explain on the theoretical part of the experiment. So, a heat exchanger is a system used for heat transfer between two or more fluids. Heat exchangers are used in cooling and heating processes. In the heat exchanger, the fluids are separated by a solid wall to prevent direct mixing and contact of the fluids. The hot stream will pass through the tube side, the cold stream will pass through the shell side. The tube exchanger used in this experiment consists of one shell and two tubes. Apart from that, control systems are integrated in this experiment to maintain the desired temperature of the cold stream.
Okay, now let us see the results that we have obtained for our experiment. First, for the PID graph, we have obtained a a graph with a derivative value of 60 and another one with a derivative value of 300. So comparing both of them, it shows that the graph with the derivative value of 300 reaches the set point faster compared to the derivative value of 60, and it's also stabilized faster, PID. Then following to PI, which is over here, first the integral value at 120 and derivative value at 0, and here at integral value at 30 and derivative value of 0. From both of these graphs, we can see that when the I value is lower, it is easier and faster to reach the set point. So this is because of the equation of 1 over tau I, which is proportional. So the lower the value, the faster we reach our set point. And for the proportional only controller, we can see that there's no offset, but it never reaches the set point. So comparing all the three controllers, we can easily say that PID is the optimum one and the most accurate one and easier to reach the set point in a shorter given time.